Hi, this is Josh from Over the Shoulder Coding, and today I'm walking through my solution for day 2 of Admin of Code 2018. I just saw this problem last night, but it didn't record with my screen recording software, so I'm going to start using YouTube live streaming to present all my solutions. So for day 2, the problem goes, you stop falling through time, catch your breath, and check the screen on the device. Destination reached. Current year, 1518. Current location, North Pole Utility Closet, 83N10. You made it. Now to find those anomalies. Outside the utility closet, you hear footsteps and a voice. I'm not sure either, but now that so many people have chimneys, maybe he could sneak in that way. Another voice responds, actually, we've been working on a new kind of suit that would let him fit through tight spaces like that. But I heard that a few days ago they lost the prototype fabric, the design plans, everything. Nobody on the team can even seem to remember important details of the project. Wouldn't they have had enough fabric to fill several boxes in the warehouse? They'd be stored together, so the box ID should be similar. Too bad it would take forever to search the warehouse for two similar box IDs. They walk too far away to hear any more. Late at night, you sneak into the warehouse. Who knows what kinds of paradoxes you could cause if you were discovered? And use your fancy wrist device to quickly scan every box and produce a list of the likely candidates, your puzzle input. To make sure you didn't miss any, you scan the likely candidate boxes again, counting the number that have an ID containing exactly 2 of any letter, then separately counting those with exactly 3 of any letter. You can multiply those two counts together to get a rudimentary checksum and compare it to what your device predicts. For example, if you see the following box IDs, A, B, C, D, E, F contains no letters that appear exactly 2 or 3 times. BABABC contains 2A and 3B, so it counts for both. ABBCDE contains 2B, but no letter appears exactly 3 times. ABCCCD contains 3C, but no letter appears exactly 2 times. AABCDD contains 2A, 2D, but it only counts once. ABCDEE contains 2E. AB contains 3A and 3B, but only counts once for that. Of these box IDs, 4 of them contain a letter which appear exactly twice. That's BABABC and ABBCDE and AABCDD and ABCDEE. And 3 of them contain a letter which appears exactly 3 times. That's BAB, ABC, ABCCCD, and ABABAB. So multiplying these together produces a checksum of 4 times 3 equals 12. So there's 4 lines containing letters that appear twice and 3 lines containing letters that appear 3 times. And you multiply the counts of number of lines with letters appearing that many times to get the checksum. So what is your checksum for the list of box IDs? So here was our input for day 2, which were a bunch of strings on separate lines. And copy that over into my input file here. And in the part 1 solution, we have a counter for counting how many lines have letters that appear twice, and a counter for how many lines that have letters that appear 3 times. So this would be like the A, B, C, C, D, E, because C appears twice. And this would be like A, B, C, 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 E, because C appears 3 times. So for each line in the lines of input, we're going to make a dictionary of the character to a integer starting at 0. And for each character that appears in that line, we're going to increment that character count by 1. Then we're going to turn those values of the dictionary into a set so that we dedupe all counts. And if 2 appears in the set, then there would have been characters in the string that appeared twice. And if 3 appears in the set, then there would have been characters in this string that appeared 3 times. So if 2 is in the frequency set, we're going to increment the twice repeating counter by 1. So this line has characters that repeat twice, so we're going to increment that counter. And same for 3. Then we're going to multiply the 2 together and get the output. And so if we run just part 1, we get 7776, which is the correct answer for part 1. So for part 2, this is how it goes. Confident that your list of box IDs is complete, you're ready to find the box full of prototype fabric. The boxes will have IDs which differ by exactly 1 character at the same position in both strings. For example, given the following box IDs, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, F, G, U, I, J, A, X, C, Y, E, and W, V, X, Y, Z. The IDs A, B, C, D, E, and A, X, C, Y, E on this line and this line are close, but they differ by 2 characters, the second and fourth, B and X, and D and Y. However, the IDs F, G, H, I, J, and F, G, U, I, J differ by exactly 1 character, the third, H and U. So this character here is the only character different between the 2 strings. So those must be the correct boxes. What letters are common between the 2 correct box IDs? In the example above, this is found by removing the differing character from either ID, producing F, G, I, J. So how do we solve this puzzle? Well, there's a simple function called Hamming distance that helps us solve this puzzle. So Hamming distance returns the distance between equal length string. So in that example where we had A, B, C, D, E, and A, X, C, Y, E, the Hamming distance would have returned 2. And for F, G, H, I, J, and F, G, U, I, J, the Hamming distance would be 1. So we need to find 2 strings whose Hamming distance is 1. And if you're curious how Hamming distance works, we check that the 2 strings are equal, and then we zip the 2 strings together, and we compare the elements in the 2 strings. And if they're not equal, we add 1 to this sum and return that. So however elements are not equal, we'll return the count of that. So if only 1 is different, which we're looking for, we'll return a 1. And we're going to make a method for finding strings of distance 1. So we're going to loop over all the lines and do a double for loop comparing each line with each other line. And we're going to strip the carriage return off the end of the line. And then if the Hamming distance of the 2 lines is equal to 1, then we'll return those 2 lines. Otherwise, if we find no lines with distance of 1, we'll return none. So we'll put these 2 things together in the solution for part 2. So we'll find line 1 and 2, the 2 lines that have a distance of 1 in our set of lines. Then we'll make a new string with all the common characters of line 1 and 2. So line 3 is going to be that new string. And for each character in the line 1 and 2, we're going to grab that index. And if they're the same character, we're going to add that character to line 3 and then print line 3. So let's run part 2. And the solution is WLKGSQ, this line. So what we did is we found the 2 strings that have a distance of 1 by comparing all strings and looking for if they have a Hamming distance of 1. And then combining those 2 strings, the common characters, if they're equal, into a third string and printing that out. So this is, a brute force solution. There might be an easier solution, but this is good enough for part 2 today. So that was our solution, and we're done with part 2. So if you like this video, please give it a thumbs up, subscribe, and I will be trying to publish more videos for Advent of Code. And if you really enjoy this series, please support me on Patreon and let me know what other series of code I should do in the future. Thanks, and I'll see you later.